Hello and welcome back to CG 101. And today we'll be tackling ECMEC 1, also known as the statics of rigid bodies. For the topic we will be tackling today, it would be centroids. And joining you today is me, Kate Ivan Kalaktai, currently taking BS Chemical Engineering. For our outlines for today, we have first our problem statement, and moving on to our theories, specifically centroids and the center of mass. Onwards is our solution, starting with the outline as well, and then moving onwards to our complete solution, ending off with our summary. To start off with our problem statement, we have to determine the x and y coordinates of the centroid of the shaded figure, in which the origin is located at the bottom left corner of the figure, marked in red. As for our theories, we have the center of gravity. It is known as the point in which all action lines intersect the object and are in equilibrium. It is also the point of which calculations for weight are made for easing of calculations. Secondly, we also have the centroid. It is also known as the location of the center of gravity of a plate of negligible thickness. This, this location is also important when making calculations on moments of inertia. Now, moving on to our solution. We are given the figure shown above, and we are required to find the x and y coordinates of the centroid. To start off, what is the calculation? What is the formula for solving the centroid? It is equal to the summation of the moments of inertia of a figure along a certain axis. So for x, it's the moments of inertia along the x-axis. Multiply that by the area of your figure. Not x-axis, it's y-axis, but the x distance from the y-axis. And that is then divided by the summation of areas. This is also applicable for your y-coordinate. It's the only difference is instead of your x distance from the y-axis, it's now your x distance. It is your y distance from your x-axis. So y multiply that by area all over the summation of area. To move onwards. So how to solve for your x coordinate first? So if you to solve for your figure, we have two different ways of solving, or two different solution patterns. We have your first one, which we just add all of the present areas, or we or the second way, which will be shown later in the complete solution, where we grab the whole figure, the whole rectangle, and then start subtracting the areas taken up by this, 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 and this. There are two different ways. So those are the two different ways. One where you just add all of this. So you add this portion. You solve the moments of inertia of this triangle, this whole this whole rectangle all the way up to here, and then you solve for this is triangle down here. You solve for the rectangle up here. Solve for the square over here, and as well as the semicircle down here. And you start adding and subtracting depending if the figure exists or does not exist. So how do you solve? So what dictates if a figure should add the moment of inertia of a shape or subtract a moment of the inertia from a shape? Well, if the figure is there, you use the plus sign, and if it doesn't exist there, it's a minus. So how do you solve this then? So for this solution that I'll be showing you, it will be it's the addition of all of the moments of inertia of the object. So first we are given, let's solve this first triangle down here. So this triangle has one base of seven and units and a height of 8 units, and these units are going to be in meters. So the moment of inertia the location of a centroid of a triangle is going to be equal to the centroid of this triangle is going to be equal to the the base or height of a triangle divided by 3, and that would be the location. The question is in where along the triangle. Well, it is going to be when you make a triangle. If this is your height, the moment of the centroid of this triangle will be one third of your total height away from the main base. So if this is one third from the bottom base, that'll be where your moment of inertia is. Same way goes for base. If this is about one third away from your base, that distance would be the location of the centroid from of your triangle. So if we were to do this is practically, so we have your x. So you have your x equal to, let's now get the area of your triangle. So it is 8 times 7 all over 2. Multiply that by the location of your centroid. So since we're gonna do x distance from the y-axis, and this is where your base is, so you have the entire length of your base, and then so that would then be 18 minus 25. That would be 7. So we have then 7 minus what's the main reason why we're doing a minus is because your centroid's over here, and it is your entire thing minus this last base location. So it would then be 7 over 3 for your first one. Then next, we are to add this huge rectangle that has multiple lengths. So how do we determine the length of our entire rectangle? First, we need to remove what we know is there. So we know this entire height, this entire section minus this triangle would be 18, but we want to remove this small triangle over here. So we have 18 minus 4, so we know the length of this other triangle, not triangle, rectangle, is going to be 14 units long. And while the other length of it, the height, would be 8. It's on the side. So we have 14 multiplied by 8, and then the location of your centroid when it comes to quadrilaterals that have 90-degree ease of length between their angles would be halfway of their base or height. So for this length, it would be your 14 divided by 2 would be 7. And yes, you might say, okay, that's good enough, right? But remember, there is an initial displacement as well from your origin. So the length is also 7. So we have 7 plus 7. So that is 14. That is our distance from your origin. And then afterwards, we also then add for this last triangle over here, this triangle down here, as well as this rectangle up here. For the rectangle up there, the dimensions of that figure would be your entire height of 8, but it is minus by 3 because of this is height down here. It's going to be the height of your triangle instead. So that would be 8 minus 3 is equal to 5. Then you multiply that 5 by your the length of your rectangle, which you know is 4 because it was labeled. And then you multiply that by the distance from the y-axis of from the centroid. So the centroid for quadrilaterals, once again, is only half of the certain length. So it's then 4 divided by 2, so it's 2. and you add that to your distance from from the origin, if no and any other additional. So it is 25 minus 2, that would be 23. So you have 23 here, and then you add as well your triangle down here, which would be equal to uh, 3 times 4 over 2, multiply that once more by, wait, excuse me, let me make this much more simpler. Where is, and then you multiply that 3 times 4 over 2 by your distance from your origin, the centroid of the triangle. Since we know the location of the base, that would be 21, since it's 25 minus 4, and we add that with length from the distance of your centroid, which would be about here-ish. So it would be 4 over 3, so plus 4 over 3. And then afterwards, we still have two figures unaccounted for, which this square over here with length of 3, as well as this semicircle down here with length of 3. And since they're hollow, you have to subtract them from your initial shape. So we have the area of your square, so it's 3 by 3, so 3 times 3, multiplied by the distance from your origin, so this point. So that would be 1.5 plus your distance from your origin, so that would be 7. So 1.5 plus 7 is equal to 8.5. And then same thing, you do work with the semicircle. The area of a semicircle is 9 pi is pi r squared, which with your radius being 3, that would be 9 pi multiplied with the distance. So for semicircles in which the axis is with your x axis, that would be a 3 plus 2 plus 3 plus 7. So that would be 8 plus 7, so that would be 15. And then this entire statement is then divided by all of your areas. So that would be 8 times 7 over 2 plus 14 times 8 plus 5 times 4 plus 3 times 2, because 4 over 2 is equal to 2, minus 3 times 3 minus 9 pi. If you were to put this onto the calculator, I shall join you for this. So that would be so that would be 28 times 7 minus 7 divided by 3 plus 14 times 8 times 14 plus 20 times 23 plus 6 times quantity 21 plus 4 divided by 3 minus 3 times minus 9 times 8.5 minus 9 pi times 15. Double checking. This nets you so that would be your numerator would then turn into 1792.05, with your denominator being equal to ooh, excuse me, 8 multiplied by 7 divided by 2 plus 14 times 8 plus 20 plus 6 minus 9 minus 9 pi. Your, and that is then going to be divided by 128.73. So your moment of inertia divided by your or sum of all areas. 13.92. Double check again for proper solution. Yep, that is the correct answer. That's 13.92 meters. For the x-axis. That is the distance from x-axis. Now now instead of our x-axis, we shall repeat the same process, but for the y-axis. So you have y. Y is equal to the summation of ya over summation of a, which for us here would be equal to, we repeat the areas again, so we know the area of a triangle, of the first triangle, which is already 28. That is then multiplied by the distance from your y-axis. Now the distance from your x-axis this time, and since the base is at the bottom, so we know this is the y-axis line here. So we're trying to find something that's about here-ish to calculate upwards. So that would then be equal to 8 over 3, because that is the height of the figure divided by 3, and since we're closer, the base is on the bottom, we have to do only 8 over 3. Then we repeat the same thing for the large rectangle, so we know the dimensions of the large rectangle are 14 times 8, which is 112. Multiply that by the height, by half the height of the rectangle, which is 8, so 8 divided by 2 is 4. And then we add that next with the height of this small rectangle all right about here. So we know the height of the figure, so we know that is, so that would be, oops, excuse me. That would then be equal to 20. And then we multiply that by the distance from the y-axis. Now note that since this square is elevated, we have to then add the distance down here, which you know is 3. So 3 plus half of the height of the figure is equal to 2.5. So 2.5 plus, yeah, so 2.5 plus 5.5 is equal to, no, 2.5 plus 3 is equal to 5.5. And then we also add the height of the triangle, which is equal to 6, the area of your triangle, multiply that by your height. So since the base is on the top, away from the thing, so we have 3 minus 1/3. Yeah, 3 minus 1/3, so that would be, no, 3 minus 1, so that would be 2. Then now we have to subtract for your square, which we know has an area of 9, and its distance would be 1.5 plus 2 is equal to 3.5, minus your area of your circle, which is 9.